Hi, my name is Will, and I've been a Java developer for over 20 years. And about 3 years ago, I decided to make a video game. The idea behind the game that I started with was Asteroids, the role-playing game. And after about a year of work in Unity, I wound up shipping the game on Steam. So the game itself is actually pretty big. It's several gigabytes on disk. It's, I don't know how much code, a lot. It's got full voice acting. It has been translated into 8 other languages, and I did all the development work myself. So that included the code, picking out and stitching together all the assets. The only thing I really got help with, besides a little bit of help on the marketing side, was obviously the translation. I couldn't translate the material into 8 different languages. And I also got help on the audio as well. So I worked with a firm to help do some of the audio mix and also on getting all the full voice acting, which was great. So I got about, I think it was 6 voice actors, and I booked each one for about an hour. I think one was for 2 hours to do all the voice acting. So other than that, all the work that you see in the game was built by me in Unity. So what I thought would be fun to do is to take some time to explain how that worked. And the way that I thought I'd do that is just sort of to pretend that I was talking to another developer, someone who maybe is like me, an enterprise Java developer. So they may be somebody who's pretty technical, but they're not familiar with Unity or how the game engine works at all. In order to make this a little bit easier for people to kind of wrap their head around, I've decided to split this up into more than one video. So this first video is just the introduction to Unity. And that's basically the idea is, like I said, it's somebody who's technical, who wants to understand how Unity works. Maybe they've been doing enterprise Java for a long time, or they're a Python developer, or whatever. So they don't know anything about Unity, though. But I don't have to explain to you what things like classes are, programming basics. So in the first video, I thought it would be good to kind of orient on what Unity is and how it works. And then in the second video, I would go ahead and actually open up the BlazeSky project itself and kind of tear into the guts for how it was built and how it was put together. Now, because I used a lot of commercial or paid assets in this project, there's no way in the world I could ever open source this. I could probably put some of the code up, but BlazeSky is just too complex, and there's like I said, there's a ton of assets that I bought and integrated into this, and so I could never make this the code for this open source. So a video will have to do. The video is the best I can do for sharing all the work that I did, and of course, I hope that if you are interested in BlazeSky, you can go up and check it out and buy it on Steam. So with that in mind, first off, I think I thought would be cool to just spend a minute or two kind of showing you BlazeSky, what the game is and how it works, and show the game to you running in the editor. You can obviously go check out the trailers, but if you haven't seen the game or you don't know what it's all about, I'm just going to go ahead and hit play on the game and kind of talk through a little bit about what the game is and how it works while I'm doing that. So this is BlazeSky, the game open up in Unity itself. There's actually only a couple of scenes in the project, which for a big RPG where there's 30 plus star systems, I think, and many planets and dozens of different kinds of spaceships and equipment and all the stuff, the game itself builds most of what's going on in the game dynamically. So I'm going to go ahead and hit play. So the launch screen is one of the scenes. And the way the game actually works is when it first launches, it actually does a little sanity check first with another scene, and then assuming that works and that the game is being run on a platform that it thinks it's acceptable, the video card is sufficient, there's enough memory, it then loads this scene, which is the opening scene. So this is just the standard boot screen that someone might see, and you'll notice that there's it says press space to begin. If you actually connect an Xbox controller or a PlayStation controller, it'll actually dynamically swap all the graphics on the UI as you plug or disconnect the controller. But for now, we're just going to stick with the keyboard. If we look here, we can see that the game is running in English right now, and I can actually go ahead and swap languages. So let's go ahead and change it to French, or Russian, or this Chinese. And so the game UI will actually dynamically update depending on the language that you select on the opening screen. So let's go ahead and go back to English, because even though I did all the work to allow the game to be localized in the different languages, I only speak English and a little bit of terrible German. Let's go ahead and look at what's in here. We've got save slots. The player has 3 different save slots they can have active at any time. I'm going to pick an empty slot. This means that now with save slot SLE, the game's never been started. I've got options for changing the audio and the visuals, and also I can even go in and change the game controls. But right now I only have the game hooked up to the keyboard, so that's the only options I have to play. And when I hit play, the first thing that happens is a cinematic kicks in. And so this cinematic is all done with an animation system, and it's got ships flying around and effects and audio, and then as the intent with the opening is to get the player kind of situated into the game. So as we can see, we're talking about FTL and colonies, and we're moving the camera around, looking at some of the spaceships. It's just a nice, fun way to get the player kind of oriented into what's going on in the game. So it's a huge space opera. There's planets, there's star systems, there's tons of ships. Like it says here, the FTL drive is invented. And so all of this is happening as when the player's getting started out. It gives the player a chance to kind of say, okay, cool, you're playing a spaceship game, you have your own little starship here. And then the game kind of just zooms in and shows you your little ship that you start out with. Now, you may have noticed a little flash there because the game engine is still loading the shaders and compiling all the assets in the background. When the player's actually playing this game for real in Steam, all of that is pre-built and pre-compiled. But when I'm running in the editor, sometimes you'll see little flashes or visual components change because of that dynamic loading. So I can go and hit space, and the game's actually going to load a new scene. So if we look over here into the scene graph, you actually see a whole new set of objects being loaded. And sure enough, I can open this up, and we can see everything that's being in the scene has already been created. We've got ships, we've got fleet markers, and the game is now giving me a tutorial for how to play. So it's giving me the controls, and sure enough, I can fly the game around. I can actually shoot. I can see he just complained when I shot him. Firing the games. I can bring up the ship's configuration. This lets me see more information about the ship. Here's all the different things that the player might acquire in the game. Let's see. So I can go ahead and close out the inventory. Now the game is saying I can switch over to the missiles and charge up missiles. But there's nothing to shoot them at right now. And I can go up to the starbase, which is right here. I can zoom in and out to get different levels of zoom. And I can go ahead and hail the character.
This is Lee Anoa. Thanks. It's my father. He's gone missing. His ship disappeared. I need you to help figure out what happened. I can pay. Not a lot, but I can pay. I just need you to do some scans for me.
So that's the very first mission that you get in the game, is to help Lee out. And I can go ahead and fly up to other things. For example, here's the shipyard. So before I jump out, I may want to go ahead and look at other ships that are available. And if I go to the shipyard, the game will zoom in and start panning the ship around and give me the options for the different ships that I have available. When I start out, I only have this one ship available. And let's go ahead and jump to another star system. So when I do that, if we look over here at the scene graph, it now has loaded a different scene, which is the star map. And I can zoom around here when I set the focus back. And let's go ahead and jump to another star system. So the game is giving me hints about the signal, and I've got a mission for scanning here. So I can go ahead and jump in. And now you'll see that the new scene is being loaded. And what's taking the time there is actually allocating all of the objects in the scene. So everything that's in the scene gets allocated up front. And sure enough, I can now do things like fly around. I can do ship scans. The game actually will subtly change the maximum speeds that are available based on what else is nearby. So if I speed it as I'm flying over to this location, this star location, the ship will actually go a little bit faster. And there was that flash again. And I'm now scanning that spot, which the game does automatically. So there's a little mini game. If I line up on the scanning line, it goes faster. And I can go up to one of these asteroids and shoot it to mine it. So these are tough crystals to defeat, and I have a pretty basic starting ship. And if I want, let's go ahead and, just to give you a little sense of the combat, I know from that if I go to over here, I'm in the home stations right now, but if I jump to the more difficult stations where there's some bases or some barbarians, then I can get into a fight. Actually, I just saw that it says there's an active barbarian fleet here, so I'm going to go ahead and fight them. So it looks like they got spawned near the comet field. So now I can see shooting them, and I've knocked down some of the health already. So I may want to zoom out a little bit. And now, because this guy, I want to do a little demo here, I'm going to go ahead and fire a missile. And now let's go ahead and use that missile. And let's that one wasn't enough, but this guy's actually running away from me. And I got him, and I picked up some stuff. So I have a starting ship, and what I would want to do is I'd fly around, I would shoot other bad guys, go on more missions. I could go ahead and do space mining if I wanted to. There's a ton of missions in the game. The star system's huge, so it's a pretty big game. It starts out really small with just me and my little ship, and as it goes on, I get to where I can fly really big ships. Even get to fly alien spaceships. It's just kind of a big game. That's the game. That's BlazeSky in a nutshell. At some point, maybe I'll record a video that kind of shows more of the mid and late game. This is just the early starting point. But in order to be able to kind of explain how BlazeSky is put together, if you haven't worked with Unity before, what I thought I'd do is go ahead and close down this project, create an empty project, and give you just kind of a quick tour through Unity itself. Okay, so here we are back at the Unity new project. It's the project hub. So if you go up to the Unity website and you download the Unity hub, this is the first thing that you'll see. And the part of the purpose of this is Unity puts out new versions of the editor and the runtime pretty frequently. And in order to make it easier to manage all the different installations of Unity that you might have on your machine, they provide this hub. So that's what this is. And if we go up here and we click on installs, you can see I've got 3 different versions of Unity already just installed on my machine already. But let's go ahead and create I've got the most current LTS version, which is the long-term support version, as of today on the machine already. So I'm going to go ahead and click new project, and we can see a couple of options. Now, some of these are for things like virtual reality or mobile 3D mobile games. To set up the settings for you. What we're going to do is we're just going to start with the most basic 3D project. You'll notice there's also one that says HDRP and URP. So this is really more intended for very high-end machines like the current generation of consoles or really good video cards. URP is a new render pipeline that's does support a wide range, and it has some of the newest features, but it's also just a little bit newer and not necessarily as widely supported. My suspicion is that over the next couple years it's going to switch over to URP as being kind of the default for folks working with Unity. But right now, the 3D standard built-in renderer is kind of the go-to, and it's also the system that I use to build BlazeSky. So we'll just go ahead and create a new project using that. So we'll call this 3D demo, and we'll put that in a folder. So we'll go ahead and create a new folder for this, just 3D demo, and create the project. So when you're working with Unity, the actual Unity engine itself, one way I kind of think of it is there's a bunch of the guts of it, which is kind of the core runtime. And then there's the editor. But the editor and the way that most people extend their game and add things to it is all done with the C# runtime. So what that means is that what we're looking at here is kind of an interesting mix of both C# and the native underlying code and runtime. So what we've got here is we've got our project file. I'm going to go ahead and dock the console over here so we can see that as well. We've got our project file over here. So this is your project. It's everything in your project. By default, the template will include just a sample scene graph. So a scene, when you see a scene, the way to think of that is it's a hierarchy of objects that are being displayed and run by the engine at any point in time. So the default for a scene is, it's just the standard one we see here is it goes ahead and it drops a camera in and it drops a light in, which is fine. And we can actually see both the game. I'm going to put the game window over here. So what we have over here is the editor view, and we can see that we've got a camera and a directional light. And when we click on the camera, we can see the inspector over here showing values for the camera. When we click on the light, we can see values for the light. So we can see it's a directional light that's actually a little bit off-white, which is probably intended to make it feel more like the sun, because we've also got a skybox set, which is defaulting to this skybox, this sort of blue and gray skybox view. So the skybox is being set by the camera attributes. So we can go ahead in here and change this to a solid color if we wanted to. So for a mobile game, or for some mini games, we might want to default it to black. But for now, we'll go ahead and leave it as the skybox. We may want to change that skybox later to be something attractive. But for now, we'll just leave it with the Unity default. So since I already made a change, you saw that flag, the dirty flag for the scene graph. So now, well, we've sort of got this idea here. This is the live scene, this is the project, and over here is the inspector. Well, let's go ahead and add something to this scene. Well, let's go ahead and add a game object, and we're just going to add a 3D cube, which is about as basic of a thing as it gets. And you may have seen it kind of turn teal and then flash, and what that was likely doing was building the shader in the background, I believe. And so when you're working in the editor, it's going to be recompiling and rebuilding the assets pretty often. So here's the cube, and we can already start to have some fun, like if we change the color of the light, for example, we can actually see that our white cube is taking on a different color because of the light being different, which is kind of cool. But let's go ahead and change the white now, not to the light yellow, but we're just going to keep it pure white just to make it a little simpler. Now the other thing we can see is we can click on our camera, and every object in this graph is going to have something called a transform. And a transform is a bit of 3D terminology that's usually used to clump together a position, a rotation, and a scale all into one concept, which is the transform. So as we tweak these things, we can actually go up here and use these little editing tools to change its position or its rotation or its scale. And there's keyboard shortcuts for that too. So that makes it easier to swap around between the different views. So these first couple ones are for positioning the objects in the screen. So if we click on the rotation, then sure enough we can rotate the camera, which is kind of cool. So now we can start to see how these objects all work together. Now if we want, we can actually start to continue to parent them. So I've got a cube here. I'm going to go ahead and create a second cube, but I'm going to put that cube inside the other one. So now if I change the position of the second cube, because it's a child of the first one, let's say I rotate these, they're going to rotate together because they've got a parenting relationship. So the hierarchy, the transforms, right? All this stuff is really the kind of the guts of this how Unity works. It's you load up a scene, you have a bunch of objects, and then they get displayed. Now, part of what's interesting here is the camera is generating some of what we see by default, like the sky blocks, and it's also got things like the field of view, so how wide or how tight the field of view is. So it's got a lot of options to be set for how to draw something. But the other thing is if we click on one of these cubes, we can actually see over here in the inspector additional components for how the cube works. So if we look at this, we can see it's got its transform, its position, and I can even go back here and reset that back to the beginning, so it's just zeros and 1 for the scale. But I've got a mesh, and the mesh is a 3D geometry for how to draw the cube. And then I've got something called a mesh renderer. So the mesh renderer looks for a mesh on the same object and says, okay, I'm going to go ahead and draw that. And you'll note that the most basic thing about the mesh renderer is that it has a default material. The default material is part of what is the material that comes with Unity. So we can see it also that material is attached to this object here, but it's grayed out. And the reason it's grayed out is we can't edit it because it's the built-in material basic guts for Unity. Then the last thing that we see on this object is a collider, which we'll come back to later. Now let's say that we want to change the material that we're using to draw the box. And so the key here is the mesh, which is the 3D geometry, uses the mesh renderer to draw the object on the screen. So let's go ahead and create over here, and you can see a ton of stuff that Unity allows you to create. But in this case, we want to create a new material, and we're going to call this red. And what we'll see is we can see that there's a bunch of options to set over here. So we can see all the different shaders. So these might be FX shaders, you might use a lightweight shader. And this is basically a shader is a little program that gets sent to the video card and tells it how to draw the thing on the screen. So in this case, the standard shader on this material is just going to render opaque. And the only thing we're going to do is we're going to change the albedo to, in this case, let's make it a nice kind of vivid blue or something. And we'll note here that there's slots for additional things to pop in. And so this might be where instead of just saying it's flat, we might override that with a texture that we bring in. But for now, we're just going to keep a flat object. And what that means is it's just going to use this color for everything. And we can actually drop that color or that material, which I called red, let's change that to blue, onto that object. And so now if we click on the cube, we can see it's got the blue material with this shader. We can open it up and see what its settings are. And then the renderer is using that specific material to render itself on the screen. So that's how we get the blue cube drawn. So it's the camera drawing the cube with a mesh, with a shape, and with a renderer, which is then given a blue material, which has the shader, and the shader is the program that's sent over to the video card. Now, this is a really flat, basic rendering, right? It's just kind of simple. It does have lighting in it, so if we move the light around, if we change the lighting, we can actually change how the objects are being drawn and how it looks, because this is a directional light. And then the other thing we can do later is add in new objects and components to customize the lighting or the rendering even more. So you may be wondering as you're looking at this, like, there's a lot of different components that are available. There's a lot of objects. And so if I go up to this game object view, I can start to see basic objects, text objects, terrain, wind, 3D text. I've got particle systems, different kinds of lights, right? All these game objects are just these empty objects, right, with components added to them. So let's go ahead and take this cube. So if we go ahead and we say, well, let's take a cube mesh. So let's go ahead and add a mesh cube, a mesh filter. And we're going to change that mesh to a cylinder. Well, now it's a cylinder mesh filter, but it's still not drawing. And then the reason that we need that is we need a mesh renderer. And now by default, we get this pink thing. So this pink one is Unity's version of saying, hey, I don't have a material for this object. And there's kind of a running joke about Unity about when something breaks, everything turns purple because the materials don't match. And now we can take this blue material and drop it on and fix it. Now we have a perfectly fine looking little blue cylinder that we've got here. And if I go ahead and reset its position, now it's sitting right next to that other object, and I can move it out of the way a little bit, and ta-da, now I have a cylinder. So I built that cylinder by just taking an empty game object and then attaching the right components to it to be able to draw it. Okay, cool. Now let's go ahead and say, okay, well, I've got all these game objects here, and we don't have time to get into all of them because that's part of what Unity is. It's just a lot of these game objects and components. Now let's go ahead and we can see also the components that can be attached to the game objects. So here we've got particle systems, navigation for doing AI movement of objects around on the screen. We've got audio, video, fancy rendering things. Here's where you can create a new skybox to change out the skybox that you're using. Tile maps, constraints for things like you only want things to be in certain positions. UI elements, obviously you might want to draw text and buttons and things on the screen, right? And then you've got things like event systems for handling UI events. So there's basically a lot of learning Unity is you've got this core game engine, but then you've also got just a million components and systems that you need to learn to be able to get Unity to do all the things that you want to do. So let's take an example of a system that's included with Unity where you kind of build out the additional behaviors by adding in the additional components. So let's take this cylinder that we built. What I'm going to do is go ahead and add a new component, and this one is going to be an animator. So in order for an animation to work, I need to go ahead and create an animation controller. And now I can go ahead and click on the animation controller and open that up in an animation window. So I'm going to go ahead and put the animation window down here. And what I'm going to do is go ahead and create a new empty state in the animator. And I'm going to go ahead and create a new animation. So we will go ahead and drop the animation here. And what we're going to do is we're going to click on this blue cylinder. And we've got the animation controller hooked up, and we have this animation that we just created, and we're going to set that as the default state. Now, I'm whipping through this pretty fast. I am creating an animation, I'm adding an animation controller, doing a bunch of stuff, right? The point on this is not for you to follow every aspect of it, it's to see how many features Unity has built in. So now I can go ahead and open up the animation window, and the animation window got put on my other screen. So let's go ahead and dock that. And I'm going to go ahead and put it over here. So as you can see, there's often an advantage to working on Unity with a really big screen. Okay, so here we go. So I've got my blue cylinder. I've attached an animation controller. to it. And I've got an animator with an animation controller, and I've created an animation, and now I'm going to add a property. And in this case, I'm going to tweak its rotation. So I'm going to start out with it flat. Let's go ahead and zoom out a little bit here and say that at the 10-second mark, I'm going to add a new keyframe and say that the rotation is 180, 180, and 180. So now let's go ahead and look at this. Alrighty, and then we go up in here and we can click on the animation and say we want to loop it. So now let's go ahead and go back into the animation. And we've got, it starts at 0. At 1 second, it got back to 0. And so let's go ahead and move these into the middle. And with our blue cylinder active, and we hit play, and we can see that it's kind of spinning. That's kind of lame. So let's go ahead and stop and remove that one keyframe. So now it's going to spin in a different way. In fact, let's go ahead and I think that we don't want to actually go back to 0. We want to go 359. 359. So now let's go ahead and start it and hit play, and we can see it spinning around. Cool. So this is an example of how Unity has a lot of features in it. So we've got physics engines and animation engines and all of these things. But if you step back from it and kind of just look at it, it's really just the scene graphs with all these components on it that allow you to build things. We can go ahead and add in physics by adding additional physics components. So this collider is kind of the starting point for that. So let's take this starting cube here, and I'm going to lift it up a little bit and add something called a rigid body. So this is saying, okay, now this is subject to physics. And I'm going to go ahead and add in another 3D object, another cube here. But this one, I'm going to kind of make it into a floor. So let's go ahead and we'll drop it down there. And I'm going to go ahead and add another rigid body. So now I've got two rigid bodies, which are the guts of the physics system. And on this one, I'm going to say it doesn't use gravity and that its position and rotation are frozen. So now let's go ahead and run the game. And what we do here is we see that the cube kind of fell to the ground. So let's just make that a little bit easier to see by changing the lighting a little bit. And maybe we take the intensity down a bit. So now let's go ahead and run. And sure enough, over here, we see that the cube falls to the ground because it's got gravity. We've got our animation playing. We've got cubes, meshes rendering, a lot of stuff pretty quick. All right, so now let's say we want to add some code to this. We want to do our own stuff. So let's go ahead and take this blue cylinder that we built, right? And let's say that we want, actually no, let's go ahead and use this blue cube. So the blue cube here is this one, the parent cube. So we'll call this one the parent cube. And let's say we want to add some behavior to it. So what we do is we go over here to component and we just type in my new component and say we want to create a new script. So I hit create and add, and what that does is it disappeared for just a second and then it came back on, and that's because Unity has now added a C# script to our project, which is the my new component script. And we can see it started at kind of a preview of the script, but we want to edit it. So if we double click, I've got my project set up to open up in JetBrains Writer. So JetBrains Writer is an IDE. If you're used to working with Java, you might be used to IntelliJ, or if you're a web developer, you might be used to WebStorm. So what's really cool is, because I'm using JetBrains writer, but it's sort of based off the same kind of core guts as IntelliJ and the other IDEs, it means that things like my keyboard shortcuts and a lot of how the projects work is going to feel really familiar. So as a longtime IntelliJ user, switching over to JetBrains Writer to work with Unity just was a very easy, straightforward thing for me to do. So we can see here, this is the class that was created for me by default. You can see that it's inheriting from the mono behavior, which is in the guts of the Unity Engine project. Or I'm sorry, it's the mono behavior is the base class. That's coming from the Unity Engine namespace. And if we open up our references here, we can actually see all the guts of the code that's available to me in my project. So all the stuff under system is basically the .NET runtime guts. And then there's a whole bunch of other things that are in the Unity namespace as well. Now, a bunch of these, like all this stuff under the Unity Editor namespace, are all things that I would be very interested in if I'm building editor extensions. And we'll come back, we'll sort of talk about that in just a sec. But then over here, you can see all the guts of the Unity engine itself that are now available to me. Everything from UI widgets to streaming to input, all sorts of things. So what I'm going to do just to illustrate this is I'm going to add in a debug line that says this game object. So I'm going to get the game object's name, and game object is available because this is a mono behavior. One of my favorite things about working in unit or with C# is something called string interpolation. And so I can see that if I run this code, what's going to happen is it's going to write out the name of the object onto the console. Now you'll see that I'm getting a little complaint here because it's saying that that's not private, so I'll go ahead and accept that. Then what I'm going to do is I'm going to add in another Boolean, and I'm going to say write log entry, and that's going to default to, it's a private one, but I'm going to actually make it public, and we'll get back to that in a moment. And what I'm going to say is whenever if write log entry is set to false, or excuse me, if it's true, then I'm going to go ahead and write something out to the console. And what I'm going to do then is I'm going to say write log entry is false. Okay, so if I have a public Boolean value here and I say write something to true, but we'll note that by default this Boolean is going to be false. So this is not going to really do anything, right? Let's go back into Unity. Here I can see this component. So I have this component script, and now I can see write log entry is showing up as a value in the editor itself. So let's go ahead and run this. So while the game is running, the objects in the scene, they get the scene graph is going to reflect a runtime scene graph right now, but it's actually not changing anything on disk. It's not changing the format for the scene on disk. And I'm going to go up to console, and we can see that the cube is started, has been written out, which is what we expected. And if I click write entry, you can see that it says hello. So if I click this, it's going to go ahead and say hello. So what's happening here is the UI is letting me, I can click it, but then in the next frame that's rendered, it processes the code that we see here. So it's as soon as the frame is rendered, if this value got set, it's instantly changing that value. So let's go ahead and go back into Unity and turn that off. So what we'll see is, I'm going to clear the console. We can see that the components here, write log entry is set, and now if I check mark it, what I'm doing is I'm saying, okay, for this cube, I want this thing to write this entry. So now let's go ahead and run. And because it's checked when it starts, then it goes ahead and writes it out the first time. So what we can see here is, in a matter of minutes, I was able to create a new component, which could be a new system that could do all sorts of things. I could move the objects around. I could turn the animations that are playing off and on. In fact, on the blue cylinder, I could add a script that would look for this animation component and then flip that script, the animation, off and on. I could change the state. For example, if we go into the animator, I might have 10 or 15 different states, and then I would use the code to control the animator to change its state. So hopefully what you're seeing here is there's this relationship between the editor, the runtime, these inspector components, and all those pieces get stitched together to make the game that you want to make. And so part of what's kind of interesting about working with Unity is you get this editor and you get so much tooling out of the box. And these tools are for things like animations or sounds or visual drawing things. And it's very difficult with many other game engines when they just say, hey, well, we've got some code to let you lay things out. Yeah, but when you're trying to do something like fine-tune the animation or sort out how the lighting should be in a scene or something, you really need the runtime capabilities as well. So you get this sort of nice combination of the developer is really writing additional little C# scripts, which you then put into the project, which then lets you build more complex stuff at scale. Now, I want to show you one other piece here that is kind of interesting about this. I've been working in this scene graph, but you might say, hey, but what happens if you've got 20 or 30 scenes and you want to share assets or share things between them? So let's go ahead and, in this project, create another scene. So this is my second scene. And let's go ahead and open this up. And now I have a second scene and it's empty because we don't have any of the stuff that we had before. So what I'm going to do is I'm going to go back to the first scene and I'm going to take this blue cylinder, and let's just say that this is something that we want to have, or we want to use this little spinning cylinder thing a lot of times. So what I'm going to do is I'm going to go back into my project here and I'm going to drag and drop the cylinder down into this. So now I've created what's called a prefab, and you'll note that it's changed blue and now it lives down in this project. And I can actually even open this up in the prefab view, which means it's not part of the scene graph, it's just part of this little cylinder on disk if I want. And here I can see in this special view the blue cylinder right here. But I want to go back to the scene. So I'm going to go click back. Now I'm back in the scene and I've got my blue cylinder. And I'm going to change the transforms for the root are not brought across for prefabs. But let's go ahead and open up my second scene now, and I can go back in and I can drag and drop this blue cylinder into my project. And in fact, I can go ahead and copy off 3 of them. And I've got my 3 cylinders here. So now when I hit play, it's picked up all the behavior of the blue cylinders because it's off the prefab on the disk, and this is how I can start to look at reusing assets. And one thing that's really cool, I actually really like about this, is I can go back in and say, open up this prefab, and let's go ahead and add another little 3D cube to my cylinder. So let's just say that that I've got this version of this cylinder with this cube on the bottom. Now let's kind of let's say it's the base of this. Cool. So you'll notice that I have the prefab open here. I have one of them here, but it's actually updating the view from the scene with all 3 of them. So even though I added the cube once over here, those cubes are also being picked up in the scene. So all 3 of those cylinders now picked up the change to the one object, which is pretty cool. Here's where it gets even wilder. So now that I've got these cylinders, let's say I've got 1 cylinder, and let's just say that I want to just disable the cube on that 1 cylinder. So I've got 2 cylinders that have cubes and 1 that doesn't. You'll notice that it's blue and actually changed up here. So if I click on this, I can click this override, and I can actually see that it's telling me that the cube has been disabled with an override, which is pretty wild. So that's how the Unity editor allows you to work with a lot of objects and reuse objects. Just lets you do a lot of stuff really fast. Now let's go ahead and let's do another one. Instead of these cubes, let's go back to the starting scene. And let's say that I want to go ahead and I'm going to create a UI. So I want to add a UI to this screen. So what I do is I go to UI, and once I want to add a button. So it's saying, okay, TextMesh Pro is the rendering system for the current version of Unity I would recommend, and go ahead and import in a couple of additional things into the project. What we see here is that now TextMesh Pro, because I've added that to the project, has now literally imported a bunch of additional things into my project itself. So these are on disk, and that's how Unity does a lot of its package management. We'll talk about that in a minute. We have this button now, and if I click on this canvas, you can see the button showing here, and if I click on the 2D button and we scroll out, now I can see my button being displayed on a view. So what I'm going to do is I'm going to take this button and I'm going to move it over a bit. And I'm going to change it so it's now linked to the bottom corner. And it's got a text component attached to it, which will just say hello. So now I've got my hello component, my button down here. Maybe I'll make it a little change shape a little bit. And because I changed the anchoring, now as I change my screen size, the hello button is rooted in the bottom corner. So let's go ahead and take this cube here. So I've got my component here, right? Let's go ahead and create a new thing. Let's go ahead and say that, so let's name it first. We've got the naming problem here. Let's change this from 2D. Double click on this. This is the ground. So I need to go ahead and rename this to the ground so I don't lose track. Got my parent cube there and another cube here. Let's see, where did we put that? Script is on this thing, and this cube here is the one that has gravity turned on. So what I'm going to do is I want to say, okay, here's my hello button, and I want to have the hello button, when I click on it, I'm going to go ahead and change this so that gravity is not on by default, but it turns the gravity on when this thing kicks in. So let's go ahead and we'll attach this behavior as a new script that we're going to put on the button. So turn on gravity. And let's just see how a really quick way of doing that might work. So I've gone ahead and created the script. Now I double click, open it up in here in Unity, and because this is only something that's going to happen when the gravity is activated, I'm going to go ahead and say turn on gravity function, which I would never do on a real thing, but for now. So what we do is we say public rigid body target, and then use gravity equals true. Okay, so what I'm saying, this is how I create a component. So I've saved this off really quick. I'm saying that I'm exposing that this component wants a rigid body, and then I'm saying that I have this function that's going to say if I call this code, I want the target use gravity to be set to true. Okay, so now we go back here. Let's try dropping in this cube. This cube, it won't accept it because there's no rigid body on that one. But if I pick this cube, it will accept it. So now I've got the cube here, and I can even go into the editor. Let's change this to physics cube. And we'll see that use gravity is on, so we'll turn that off. Let's go ahead and try running this. And here's my cube spinning around with its animation that's playing in the ground. I've got my two cubes, and when I click hello, we forgot to wire up the button. Let's do the last bit here. So we'll click on the button, and what we're going to do is we're going to say on click, and we're going to just try dropping that in with this button, and when we say turn on gravity, call our turn on gravity function. So this button calls this script. Run, and now when we click on the button, gravity activates and the cube falls to the ground. Pretty cool. Okay, so we showed a lot of stuff really quickly. We've got C# scripts that we're adding to our project. Let's do one last little bit, which is the package manager function. So if I go up here and I bring up the package manager. This is, first off, it's showing me all of the packages that are in use in my project already. So we have text mesh. We're using Unity UI. By default, it includes version control, and I'm using the writer editor. But what I'm going to do is I'm going to go ahead and switch to my assets. So these are all the assets that I bought off the Unity asset store. And there's a lot. I did buy a lot of assets over time. Unity, just like Steam, is really good at offering a lot of sales on really cool kits, and there's just a lot of stuff that's available. So we can scroll through here and see some of the things. Some of these are free things that Unity makes available. Some of these are editor extensions. For example, the Odin is actually a tool that enhances the project itself inside of Unity to give you a different tooling. Because I did a spaceship game, of course I've got all sorts of kinds of planets and spaceships and things. One of the packages that I'll be talking about later is Rewired, which I use to handle all of the control systems that for when you click on things and make stuff happen. What you'll find is that these assets are hugely different in terms of their quality level and what other systems in Unity they're compatible with. So for example, here's some crystals. So these are tiny little crystals. They've each got different levels of detail, but one of the questions you might have is, well, does this asset work with a particular rendering pipeline that you're using with Unity? So whenever you're looking at stuff, you have to kind of do a little bit of homework to figure out if they're quality or they work or how they work. So for this one, let's just go ahead and hit download. So the first thing you'll do is go ahead and grab it off of the Unity asset store. This one's only 1.65 megabytes because these are just a couple of tiny little crystals. You know, even something as simple as a spaceship with a lot of detail or a lot of different textures on it could get very complicated very quickly. But let's go ahead and bring these in. So looking at this, we can see it's got some animations, it's got some materials, it's got the mesh, and then they've even built some prefabs. There's a demo scene, there's a special shader that they've included, and they've also got some crystals, textures. So let's go ahead and hit import and take a look at what we got here. So when I import something, anything into my project, it'll download it onto the machine locally, kind of like a Maven repository, but when you actually add it to your project, it doesn't just include a reference to the asset. It's going to copy the whole asset and everything involved into your project itself. And this is one of the biggest differences between working with something like a typical Java project, where if I include, let's say I'm working with a Java Spring Boot project, I might have all the libraries and dependencies on disk, and Maven is perfectly happy to include those references in my project, but I actually have to check all that into my project itself. In Unity, a project will have all of everything it needs that's not in the base editor. I have to bring it into the project and actually copy those assets directly into my project. So this is one of the reasons why a project on Unity's, like the Git repo, can start to get really big, because if you start copying in a lot of assets, a lot of art, a lot of sound, 3D meshes, 3D textures, it can get really big really fast. So here we can see our crystals, and I'm going to go ahead and look at the prefabs. Here's a blue crystal, and we can drop it into the project. And let's go ahead, and there's my crystal. Now it's not drawing terribly well, so that's a good question as to why. Let's go ahead and hit play, and I think it's because the shader isn't compiling and rendering nicely. And sure enough, it's animating, but it's not drawing. So this is an example of going in and looking at the crystal and figuring out what shader to use. So I'm going to change the crystal to just be a standard shader instead. So now I'm changing how it's drawing, and we can go and look at the materials, and sure enough, crystal blue is not rendering. The crystal unlit, so it's got an occlusion, some texture tiling. This is a perfect example of the kind of challenges that you might run into, where if the assets aren't built properly for the game, you may wind up having to redo them. So almost certainly the issue is that there's something about this shader that's not playing nicely with this version of Unity. Which is a bummer. But then what I could do is I could go in here and change the crystals. Now this crystal has 3 levels of detail. So what that's saying is that as I zoom in and out, in fact you can kind of see how the crystals, if I look at it in the editor here, when I click on it, it's changing it to different levels of detail depending on how far away I am. All these little pieces fit together. I have a couple of choices. I might go ahead and rebuild a new material with this. I might say, oh, well, these aren't that complicated a set of meshes. So let's go ahead and say I want the most detailed one, and I'm just going to pop it out and say, okay, I only want that thing, that particular one. So I hit copy, go back here, hit paste, delete the one that I had initially. There's the level of detail, and let's go ahead and on the materials for this one, this crystal blue, I'm going to go ahead and change it to actually fade. And I'm going to go ahead and set the albedo to pretty close. So now I've got a blue crystal that's got some transparency to it. And now I have a crystal that looks pretty cool. And if I wanted to get fancy, I might paste and create another one. Put it as a child, scale it down to 0.8. So now I've got one crystal inside the other, and I'm going to create a second material, which I'm going to drop onto this one. And on this one, I am going to let's make it a little bit more teal looking and a little bit more opaque. So now I've got this kind of spooky crystal thing going. And if I hit play on it, there I've got my crystal drawing, my thing there. I'm looking at that. All right, it's just playing around, but you get the idea. I'm pulling assets in. I'm having to tweak the asset to get it to work in my project. I'm trying to build my UI, all of these different things. So I think that's enough for now to give you a kind of a good sense of what it's like to work in Unity, how you are mostly as a developer adding additional components in. You're working with scene graphs. You can create objects in code. You can then get their components very easily, and then you can then make changes and modifications. So hopefully that's enough to kind of get you oriented. And one of the things I think is important is to understand how all these visual tools then play nicely with the code. So it's just a cool environment and a fun thing to play with. So that is my quick high-level introduction to Unity. I hope it was useful and helpful for you. And check out the next videos where I'll be talking more about how BlazeSky works. All right, thanks. Bye. Don't forget to like and subscribe and all that good stuff. Talk to you later. Bye.